In the previous video, we understood the significance of math box manipulators and more specifically algebra tiles in algebra. Most of the algebra activity sheets in grades 6, 7 and 8 use algebra tiles. In this video, you will learn how we use algebra tiles to represent and work with algebraic expressions. It is recommended that you use the algebra tiles in your math box along with each video so you can follow it better. By the end of this video, you will be able to answer the following questions. What shapes do the algebra tiles come in? What do the colors signify? What value does each tile represent? Well, what are algebra tiles? Similar to abstract symbols like X, Y, etc., algebra tiles are just placeholders used to represent unknown quantities. They can be used to represent algebraic terms like x, 3x, x squared, and so on. Let us see how algebra tiles are used to represent unknown quantities. Now, algebra tiles consist of different shapes, each representing a certain value. We will refer to them as big blue squares, big red squares, blue rectangles, red rectangles, small blue squares, and small red squares. As you can see, we have two different colors of tiles. Do the colors have any significance? Every shape, as you can see, is available in two colors, blue and red. The blue tiles represent positive values, while the red tiles represent negative values. The value each shape represents is based on the area it occupies. For example, we assume that the length of each side of this small square is 1 unit. So, it occupies an area of 1 unit square. So, we use the small square to represent the value 1. Since this is blue in color, it represents positive 1. So, naturally, to represent the value of positive 3, we use 3 small blue squares. Observe here that the length of the side of this square, being 1 unit, is simply an assumption. The actual length does not matter as long as it is uniform across all small squares. Before we move on, let's understand what x denotes. In algebra, x is used to denote an unknown quantity. So when we do not know the value of something, we refer to it with a symbol, usually x. This presents a problem. How do we represent an unknown quantity with a tangible object, more specifically an algebra tile? For representation purposes, we use these rectangles to denote an unknown x. So, similar to the representation of 1, we assume the length of this rectangle to be x units. And you might see that the breadth of the rectangle is equal to the length of the side of the small square, that is 1 unit. So, the area occupied by the rectangle is x units squared. Hence, it represents the value x. You might also observe that the length of the rectangle that we've assumed as x units is roughly 3 times the length of the side of the small square. Does that mean that the value of x is 3 units? Not really. Remember that x is simply a placeholder for an unknown quantity and not a fixed value. To represent this unknown, we simply want a tangible placeholder with an area of x units squared. So the actual measure of the rectangle's length is immaterial. This is in fact the beauty of algebra as a concept too. The fact that we can play around with terms without knowing their actual value is a very profound idea in itself. So to represent positive 2x, we can use 2 blue rectangles. Comparing the length of each side of the big square with the length of the rectangle, we can say that this length is x units. So the area occupied by the big square is x square units squared. So it represents the value x square. The fact that it is blue again signifies the value positive x square units. So to represent 3x square, we can use 3 big blue squares. We've so far discussed the blue colored tiles. As we saw before, red tiles represent negative quantities. Does that mean these tiles measure negative values? What does it mean really for the area of a shape to be negative? Well, area is a positive quantity, of course, So the positive or negative sign is just assigned for representation purposes. And this is done with the help of two different colors, blue and red. So while the areas of a blue and a red rectangle are the same, they are assigned a positive and negative sign to help us visualize them. So similar to a big blue square, a big red square denotes negative x square. So the red rectangle would represent negative x and the small red square would represent negative 1.